Today's lab is response of second order RLC circuit. In second order RLC circuit, there are two types of response: natural response and step response. In natural response, there is no power source like voltage source or current source, so a circuit behave on its own, like values stored in capacitor or inductor. For natural response, this is the given condition for underdamped response, overdamped response, and critical damped response. In underdamped response, the, the graph will gradually decreases in the regular manner. In overdamped response, the graph behave like this in this picture. And similar case is for critical, but the graph move more faster than in overdamped response. This is the formula for the calculation also mentioned here. From this formula you can easily select any inductor or capacitor or resistor value, like I choose 8 millihenry for inductor and 2 microfarad for capacitor. So I can find the value of resistor for critical damp condition, so I can easily find the response of a circuit. Let's take inductor first of all. In place it, you can press Ctrl plus R to rotate it. Similarly for capacitor, you can grab any capacitor and change its value, it doesn't matter. Don't forget to put the ground. Okay, let's join the wire. Change the capacitor value. Capacitor value is 0.125 microfarad. 0.125. For micro you can press U, and initial condition is given is 5 volt. 5. Similarly for initial condition of inductor is 0.5 ampere. It's 20k. Now let's see the natural response. For this, go to the simulate and analysis and simulation. There is transient response, initial condition set to 0 and time 0.05 as mentioned in lab, but you can change it to see the graph in different position and check this for. Now you can see this is the underdamped graph. The graph is decreasing in a regular manner, so this is the underdamped response. Similarly, you can find the overdamped response and critical damped response. The resistor values is already given in the circuit, so you find it by yourself. Now let's find the natural response of a series circuit. I'm taking the same values mentioned in lab. You can take any values and calculate by using the formula mentioned. 8 Henry with initial condition is 0.5. Zero point 125 micro with initial condition 5. I'm changing the time limit so I can see the graph clearly for under damped condition. Now let's talk about the step response of an RLC circuit. In such step response, we are taking the power source, DC power source, to analyze our circuit. Let's draw the series RLC circuit to find the step response. In step response, we are taking the DC power source. You can take any DC power source value, it doesn't matter. I'm taking the resistor value say 100 ohm. I'm changing this resistor value to 100 ohm. As mentioned on the screen, I have written the calculation and also mentioned the formula to calculate the value of resistor. So you can easily change resistor, inductor and capacitor value of your choice. 2 micro for capacitor. Okay, let's go to simulate, analysis and simulation. Initial condition set to 0, time 0.005. In output at V3 volt, we are seeing the voltage across capacitor. So at V3 and let's run.
C4C.
This is the critical response. Now let's see the underdamped response. For underdamped response, R should be less than 100, so the circuit behavior, the transient is under damped. Now we will change the value of resistor and like 50. If resistor value is less than the formula given, the response is under damped. So let's put, for example, 50. You can put any value of your choice, it doesn't matter. Let's run it. Now you see this is the under damped response. It is in the regular manner and decreasing in the regular manner. Okay, let's see the overdamped response. For overdamped response, R should be greater than the formula given. Now you can see the overdamped response. Similarly, the critical response. In the last part, let's see the step response of a parallel circuit. In this case, we are going to choose a DC current source. Why we are choosing the DC current source, not the DC voltage source? Because while using the DC voltage source, you will going to get the error like inductor is overlooping, etc. So we are choosing DC current source. Let's place it and ground. Let's join it. By the formula mentioned, you can choose any value of capacitor, like I'm choosing 2 microfarad capacitor and inductor 8 millihenry inductor. So I can find the value of resistor for critical oscillation. By calculation, I find out the value of resistor is about 35.5 for critical. Let's run the circuit. Transient, initial condition set to 0. Output V1 add. Okay, let's run it. This is the graph for critical condition. Let's change the value 5. In parallel step response case, the condition is opposite. Unlike in the series case, you have to decrement the value of resistor to get the under damped condition, but in this parallel case you have to increase the value of resistor to get the under damped condition. So this is the under damped condition. Now let's find the over damped condition and end this lab. We have to decrement the value of resistor, like 35 was for critical condition, and let's take 10 for over damped in parallel circuit. This is for the over damped condition.